Welcome to the Pencast video of exercise 11. Obtain all possible real-valued solutions for m and phi that satisfy the following equation. 5 times the cosine of omega t should be equal to m times cosine of omega t minus pi over 6 plus 5 times the cosine of omega t plus phi. To start this exercise off, we'll first write the cosines as real parts of a complex exponential. So what we'll get is the real part of 5 times e to the power j omega t, which is equal to the real part of m e to the power j omega t minus pi over 6 plus the real part of 5 e to the power j omega t plus phi. What we'll do next is we'll separate the e to the power j omega t. This will give us the real part of e to the power j omega t times m times e to the power j minus pi over 6 plus the real part of e to the power j omega t multiplied with 5 e to the power j phi. What we'll do now is we'll make use of the Phasor addition rule, which simply states that we can subtract or add different complex exponentials which correspond to the same angular frequency. So since omega is the same in this case, we have the same omega everywhere, we can simply add these things all up. So what this will give is the real part of e to the power j omega t m times e to the power minus j pi over 6 plus 5 e to the power j phi. What this means for our initial equation is that we have both the real parts of something multiplied with e to the power j omega t. So what this means is that our 5 on the left hand side should be equal to m times e to the power minus j pi over 6 plus 5 e to the power j phi. So let's write this equation out. 5 is m times e to the power minus j pi over 6 plus 5 e to the power j phi. For now, let's multiply both sides of the equation with e to the power j pi over 6 to separate the m from the rest of the equation. So this will give us e to the power 5 e to the power j pi over 6 is equal to m plus 5 e to the power j phi plus pi over 6. So to solve this equation, we have to do two things. First, we have to convert these complex exponentials back to a real part and an imaginary part, and then we have to solve the equations corresponding to these real and imaginary parts. So first, let's write the e to the power j pi over 6 as a complex part, as a real part and an imaginary part. So we'll get 5 times the cosine of pi over 6 plus j times 5 times sine of pi over 6, which should be equal to the real m plus 5 times the cosine of phi plus pi over 6 plus the imaginary part 5 times the sine of phi plus pi over 6. So let's write, so for this equation to hold, the real parts on both ends should be the same as well as the imaginary parts. So the first equation is the imaginary equation. We'll give 5 times the sine of pi divided by 6 should be equal to 5 times the sine of phi plus pi over 6. The 5's will easily cancel out, and this will leave us with a simple equation. As can already be noted, phi, a solution is that phi is of course equal to 0, because that leaves us with sine pi over 6 and sine pi over 6, which is equal. However, there's also a value which is, there's also an angle for which the sinusoid has the same value. And in this case, that is sine 5 pi over 6. These are identical. And this leaves us with a second solution, namely phi is equal to 4 pi over 6, which is equal to 2 pi over 3. So let's find m for these different values of phi. So we get 5 times the cosine of pi over 6 is equal to m. This is for the case phi is 0, by the way. M plus 5 times the cosine of 0 of phi plus pi over 6. So in the case of phi is 0, we'll simply get the cosine pi over 6. So those two will cancel out. And what we're left with is the simple equation of m is equal to 0. So for the case phi is equal to 0, m should also be equal to 0. So this is our first solution. Now for the second case, where phi is equal to 2 pi over 3. If we fill this one in, we'll get 5 times the cosine of pi over 6 is equal to m plus 5 times the cosine of 5 pi over 6. The cosine of pi over 6 is equal to 1/2 square root of 3. And the cosine of 5 pi over 6 is equal to minus 1/2 the square root of 3. So this will lead to our final answer of m should be equal to 5 times the square root of 3. So in this case, our second solution for the case phi is 2 pi over 3 is for m is equal to 5 times the square root of 3. These two solutions are our final answer.